So now we could, without going into the exact details of, the drawing the exact circuit, we could even ask, well, if I wanted a 7:128 decoder and I wanted to build it using a, just 3:8 decoders, how many decoders would I need? Okay, 7:128 decoder. Okay, using 3:8 decoder. So I will stop using the word, with enable, because I assume by default all the decoders come with an enable, right? So now the first step is, if I want 128 outputs, okay, I need, so this is the inputs to this decoder. Okay, let's just draw the block diagram first. Okay, this is 7:128. I have 7 inputs, right? So this is going to be A6, A5, A4, A3, A0. Okay, and my outputs are going to be Y0, Y1, all the way down to Y127. Okay, and I have an enable here, right? So it's very simple. Obviously, you take the lower bits, A0, A1, A2, the LSB 3 bits, right? And you see, each of that can give you if you connect it to a 3:8 decoder, you can get 8 outputs. At the output, I want 128 outputs. Therefore, the number of decoders, right, in the final logic stage. So let me just look at this. So I have this, let me call this logic level 2, level 1. Okay. So actually no, I will call this level 1, I will go from the output. Okay, the one that is closest to the outputs, primary outputs, is what I will call level 1. Okay, just for because I really do not know how many levels I need for this. So in my level 1, what do I need? I need 128 outputs, right? 128 divided by 8. I need that many decoders. Okay, how many? So 128 by 8 is how much? How much is it? 2 power 7 by 2 power 3. So I need 16 such decoders. Last time in the 6:64, I needed 8 decoders. I need 16 such decoders now. Okay. So yeah, good. I already have this. So I will, right? So I have decoder D0 and I will go all the way to D15 in level 1. Okay, and the outputs are obviously going to be Y0, Y1, Y7, and this will be Y127, 126, 127, 126, 125, 124, 123, 122, 121 and 120, right? So why, I think it should be this. Yeah, I think it should be this, because it will be 0, 8 and 120 is indeed divisible by 8. Yes. Okay. So this is how I am going to get the decoders at the output at level 1. Okay, at closest to the primary outputs. So A0, A1, A2, same thing here, A1, A0, right? And now, which are the bits that are going to enable this, each of these decoders that I want here. Okay, so now what you see is, effectively, if you look at this earlier design, what we said was the hierarchical design of this, larger decoder with smaller decoders was you place as many decoders as you need at the output level, and then you need an other decoder to enable one by one depending on the higher order bits. Okay, so basically you had level 1 which had a 3:8 decoder, and level 2 also was another 3:8 decoder. Okay, you had essentially, this is what we needed. Likewise, what we need here is actually a 4:16 decoder, okay, which takes the higher order bits that we have, okay, A3, A4, A5, A6, right? Actually, this is exactly what I want. Okay, this is going to be the 4:16 Y0 all the way to Y15. Okay, and I would have put the enable here. But I don't have a 4:16 decoder. Then what do? I need to build a 4:16 decoder using 3:8 decoders. Okay, so again we come back to, that's why this is called a hierarchical design. We started with, okay, 7:128, then we came down to 4:16. 4:16 needs to be broken down further using 3:8 decoders. Okay, so how do I now do a 4:16 decoder? Again, using 3:8 decoders. Right? So here again, what do you do? Four is to 16, therefore its output stage should simply be its output stage Y0, Y1, Y7, Y8, Y9, Y15. Okay, and what are the inputs I will connect here? Now the 4:16 decoder, let's draw the interface here. Okay, I will call this B3, B2, B1, B0, so that I don't want to confuse with the and I will call these outputs, I will call it X0 to X, X1, X7, X8, X9, X15, right? So these are my things. So I'm going to call this, I will connect B0, B1, B2 here, same thing, B0, B1 and B2. Okay, my outputs are going to be X0, X1 all the way down to X15, right? In fact, to stay in line with the convention we had used, I will draw the lower order, the address bits here. Okay, this is B3, B2, B1, B0, and the enable will appear here. This is my 4:16 decoder. Okay, so I have X0 to X15 here. Now I have taken care of the bits B0, B1, B2. I need to now account only for. So now on the having built my the level that is closest to the output using 3:8 decoders, I just need a 1:2 decoder on this side. Okay, and therefore we already saw this, how to build a smaller decoder using a larger decoder. So that's nothing but we are going to connect B0, so this will be B, and these bits will be connected to the input 0, they will be grounded, okay, and you take only Y0 and Y1 here, okay. So this is essentially a 2:1 decoder, and this is a 1:2 decoder, sorry, and this is a 3:8 stage, right, and this is where my enable of this block will come, okay. So B4 is connected here, B2, B1, B0, and then I am going to connect it to that. So all I need to now do is to replace this 4:16 block using this hierarchical design that I basically got here, right. So effectively, this is all dot dot dot, by the way, okay. So let us go ahead and do that, right. So I will take this 4:15 block, okay, and I am now going to replace it with my hierarchical design that I got from here. Yeah, okay, I have this nicely done, and all I have to do now is connect these, these are my lower order bits, and therefore what I need to do now is this 3:8 decoder on at the the previous stage, which is basically the 4:16 decoder that we have built, right. That needs to be controlled with bits A3, A4 and A5, okay. So I'll connect this to A3, A4 and A5. This is A3, A4, A5, and this bit, address bit, needs to be controlled with A6, and the outermost decoder will have to be controlled with its enable signal, right. So with that, what you see is we have now been able to build the 7:128 decoder as well using this 3:8 decoders. Again, how many did we need? Okay, so you start from the outermost level. Okay, we needed 128 outputs, and therefore we needed 128 by 8 at. So there are multiple things that we need to do here. First, we need to figure out how many levels of logic we needed, okay. So this is my level 2, okay, and this is my level 3. So you need, first of all, 3 levels of logic in this case, right, to get the entire design going. So how many at level 1? You needed 128 by 8, which is 16 decoders, right, and then you needed a 4:16. The 4:16 basically had 2 levels, okay. So in level 2, when you implement it, as you see here, you need 16 by 8 equal to 2 decoders, and level 3 is basically the so 2 is already implemented into so it's like this, yeah. So you need one decoder, right. So why? Because 2 is less than 8, right. So basically you started with this 128 that appears here, right. Then you take the 16, divide by 8, you get this. Likewise, you go here, and you have to keep doing this until you have reached a point where you can implement whatever you want with a 3:8 decoder without having to go any lower than that, okay. And therefore here we needed how many? 16 plus 2, 18 plus 1, 19 decoders in order to get this design right using 3:8 decoders. Okay. So, one obvious extension of this idea is to just look at, you know, what if my decoder output number was not a power of 2, right? So, for example, I may want to do, you might land up in a situation where you need a decoder which gives you 52 outputs. That is Y0 to Y51, are the output pins. One of them has to go high, and therefore you need to construct this using some decoder. Okay. So, the first point to note here is that if you have 52 outputs, right, you have to find the the number of bits that you need to control this. Okay. So, 52, so you got to find is greater than 32, right, and it is less than 64. Okay, this is 5 bit, this is 6 bit. So, you need 6 bits in order to build a whatever input to 52 decoder. Okay. Now, if you have to do this, then you pick a 6 bit decoder, and you know how to build a 6:64 decoder. Okay, we already saw that, so I will just go ahead and copy that in order to get this. Yeah, so I'll just write this. What I want is a 52 output. Okay, yeah. So, therefore, I need a 6:64 decoder. So, I need bits A0, A5, A1, A5, A4, A3, A2, A1, A0. 6 bits I need. Okay, the only point is you don't need as many decoders in the output going all the way to 63. Okay, so therefore, what you have to do is you can simply cut these decoders off once you reach 52. Okay. So, for example, again, if you are building it with 3:8 decoders, you can go only in multiples of 8, right. So, instead of going from, instead of putting 8 decoders D0 to D7 at the output, I would simply put only as many decoders as needed so that I go up to 52, right. So, 52 again is, 7 8s are 56, right, and therefore, instead of going up to D7, I will go only up to D6, okay, and in which case my output will be Y57, 57, 56, 55, 54, 53, 52, 51, and no, it has to be, no, it cannot be this, it has to be Y0, Y8, it has to be Y55, right, and let us see. So, in that case, this could be Y48, correct. 6 8s are, yes, 6 8s are 48, you will get that, and 48, 49, 50, 51, 52, 53, 54, 55, 8 outputs, right. So, this is 49, okay, and then you will go all the way till you get your Y51, okay, and I am going to simply ignore the other outputs of this decoder D6, right. So, all I will do is I will use 7 decoders in my level 1, okay, L1, I will use 7 decoders. L2 obviously is 1 3:8 decoder, right, and I am just going to leave out the other combinations, and I will get a 52, 6:52 decoder if I need it, right? So it's you must remember that just because we are thinking in terms of power 2, the hardware need not always scale in powers of 2. Like here we are able to leave it out, right? And we are able to this thing. So for example, even if you wanted a 6, let's say you wanted 34 decoder, 34 output decoder, right? Again, 34 is greater than 32 but less than 64, so you need 6 bits. But again, the only point is you don't need to go all the way to D6 or D7 at the last stage. Okay, so you can easily, in this hierarchical design, make a calculation for the number of decoders that you need and figure out how your design must scale in terms of these hierarchical blocks that you are building. Thank you.